Okay, here we go with the notes for our 10.2, simplifying radical expressions. Again, in the past, we were pretty much grabbing a calculator and taking the square roots of things and estimating answers. What we're going to do is we're going to learn a technique of simplifying radical expressions and having exact answers. So what is a radical expression? Anything that involves a radical sign, square root of 50, 2, radical, 4. You could even have expressions underneath that radical sign, all right, and they could get more complicated. We're going to stick more with these simpler ones, the simple ones here. So these are radical expressions. You know, we have the radical sign. The stuff inside is known as the radicand. And what we wanted to do is to simplify these. Basically, what the idea is we want to take anything that's under the radical sign, any perfect square factors, and take them out. And whatever's not a perfect square factor, we just leave. When is a rational expression simplified? So, or radical, not rational, sorry. A radical expression is simplified when a couple of things happen. First, the radicand has no perfect square factors other than 1, because one's always going to be under there, but other than 1, you can't take anything else out. Okay, so the radicand has no perfect square factors that remain other than 1. Second rule for it to be simplified, the radicand can't be a fraction. We'll deal with that tomorrow. So if you had like the square root of 5/7, that would not be considered simplified because our radicand is a fraction. And the third thing, again, which this is another thing we're going to deal with tomorrow, no radicals can be in the denominator. So if I had something like 5 over the square root of 3, that's not considered simplified because I have a radicand in the denominator. Okay? And just like, I didn't give you an example for the first one, but if you were to say the radicand has no perfect square factors, this would not be simplified because inside here I know that 25 times 2 is 50 and 25 is a perfect square factor, so I didn't want to take that out. Okay, and a couple of things that we can recognize, some rules for radicands. If I have radical a times b, I'm allowed to break that apart as radical a times radical b, or the square root of ab equals the square root of a times the square root of b. Why is that important? Because we're going to use that to help us with this first rule here. So let's say we go to that example of square root of 50. And just writing this out long ways first. Once you start to do this more and more and more, you can start to eliminate steps or do steps mentally. But using this procedure here, I could break this apart as the square root of 25 times 2. And this rule states that if I have that, I could write this as the square root of 25 times the square root of 2. And the square root of 25 is 5 radical 2. And now we have a simplified form because I have no perfect square factors left in here. Okay, and we're going to work with 2 and 3 more tomorrow. I want us just to practice this skill today. And you would write this as 5 times the square root of 2, or you might hear people say 5 radical 2. All right, that's what we're looking to do. We're looking to take out perfect square factors. So let's say you had the square root of 48. You might ask yourself, well, I don't know, are there any perfect square factors of 48? And some people might see it right away. Other people might not. Some people might think, okay, 4 times 12, right, that works. Other people might see 16 and 48. But what we could do is just break this guy apart. And let's say you did 4 times 12. this would be the square root of 4. And what you're going to end up seeing me doing is, instead of kind of writing this step out all the time, once I get a perfect square factor, I circle it, I'm taking that guy out. What's the square root of 4? 2. So I put that 2 to the front. A common mistake is people stop without finishing this. And you say, oh, there's our answer, 2 radical 12. The problem with that is square root of 12 still has a 4 in it, right? A factor of 4. So I have to take that out as well, which ends up being 2 radical 4 times 3. So you always got to check your radicand and make sure it is totally simplified or doesn't have any perfect square factors. Now I can take out the square root of 4, which is 2, right? When I take that 2 out, I end up getting 2 times 2, right? There's a number out here. I'm multiplying it, radical 3. And I can multiply 2 times 2, I get 4 radical 3. That would be my simplified answer. If you were to do 48 in a little different way, and you recognize 16 times 3 is 48, that gets you to your answer faster. And you can say, well, the square root of 16 is 4, that would go to the front, radical 3. That's the same answer as that. And another way of doing that would be if you wanted to use primes. Let's say you took 48 and you factored it into primes. So when I did this, I don't know if you guys recall how I did this in class. I just took out the smallest prime each time. So 2 goes into 48, that'd be 24. 2 goes into 24 12 times. 2 goes into 12 6 times. And then 2 goes into 6 3 times. Once we get a prime number here, this guy's factored into primes. 2 times 2 times 2 times 2 times 3. So I can break this apart this way, where I do 2 times 2 times 2 times 2, and this always works as well. It's another technique if you can't find perfect square factors. Now when I do it this way, I know 2's not, these are prime numbers, so they're not perfect squares, but anytime I have partners in here, what's 2 times 2? That's 4. The square root of 4 is 2. I could take a 2 out. I have another set of partners. 2 times 2, that's 4. The square root of 4 is 2. I can take another 2 out. And I can bring those 2 out to the front, so it's 2 times 2 radical 3. Same thing we had up here, so 4 radical 3. All right, that's another way of doing it, where you can look for partners if you want to break it into its primes. Okay, it doesn't really matter which technique. We're looking to take out perfect square factors. What happens if we have variables inside here? So let's say it's x to the 6th power. We have radical x to the 6th. Well, if you recall, the square root symbol is just a fancy way of writing to the 1/2 power. So this is x to the 6th to the 1/2. And if we use the make it rain rule here, we'd have half of 6 is 3, and there's our answer, x to the 3rd. So without writing this out each and every time, I know that basically if I have a variable underneath the radical sign, if it's even, I'm going to take half of them out, and there's nothing left under the radical sign, right? So the square root of x to the 6th is x to the 3rd. Think about that. What number times itself is x to the 6th? X to the 3rd. If it's an odd number under here, what ends up happening is I can sort of break this apart into x to the 6th times x using that technique we did above, right? That would get me x to the 7th. And the reason why I like to have even is because when I take half of 6, I get 3. So I'm going to take x to the 3rd out. That just moves to the front. That other x would remain where it is. So I get x to the 3rd radical x. That would be this guy simplified. Okay. Let's say we have one a little bit more complicated. We have 2 radical 54 n to the 10th. And if there's a number out front, that just is, there's a multiplication sign between here and here. So that doesn't really mean anything in terms of, it's not under the radical, right? That's by itself. That's a separate factor. So what I want to do is whatever comes out of the radical is going to be multiplied by 2, whatever's out front here. I look at 54, and you might be thinking, I don't know what goes into 54. That's a perfect square factor. But then I start thinking, okay, 9 times 6 is 54. So that's where I begin. So I'm going to rewrite this as 2 radical 9 times 6 times n to the 10th. I don't really want to do with anything to n to the 10th right now because it's an even value, so I'm going to be able to take all of them out. This guy's a perfect square, so I'm going to take a 3 out, right? Square root of 9 is 3. This guy's a perfect square, right? How am I going to take out? There's n to the 10th underneath the radical. I'm going to take out n to the 5th. So I do 2 times 3, which is 6, n to the 5th radical, and whatever's left stays under the radical sign. And now I just do a quick check. Square root of 6 is pretty much done, right? 2 times 3, there's nothing more I can do there. That is its solution. So that's the process today. It's a little different. You probably haven't done this before. Well, I know you haven't done this before, so it's going to be a little bit of a challenge at first. Okay. So just looking at the paper I gave you, look for perfect squares, right? 25. So that's going to be 25 times 5, I believe. So this is 25 times 5 times n under the radical sign. I take, and this guy can be factored out. The square root of 25 is 5. So this would be 5 radical 5n. That's what I could do there. Calculators, even though we're not just taking the square roots of them, they could still be your friends here. If I do 216 and divide that by 36 to see, whoops, clear. 216 divided by 36. I'm just checking to see, and I recognize that 36 times 6 is 216. If you don't see that, just, again, we can break this apart. So this is 36 times 6 times v, all under the radical sign, which means I can take this perfect square out as a 6 radical 6v. Nothing more I can do. Alrighty. And I'm trying to see what else is on here. So there's some different ways of doing it. If you had number 6, the square root of 100 times v squared times v. Okay, again, if it's an odd, I break it apart as to the 1 and then times 1 less than that. Because if I add these up, I'm here. This guy's a perfect square factor, so a 10's coming out. This guy's a perfect square factor. Remember, you take half of them out, so a v is going to come out. 10v radical v is how I simplify this. Okay, so try those out, and I did attach the answer to this as well, so you can check to see how to do that. Like I said, if you can't come across a perfect square factor, just start with like 4, right? 4 goes into that. Figure out what 512 divided by 4 is, and if I did that, 512 divide that by 4, I get 128. So 4 times 128 times m squared times m. I could take this guy out, and I could take this guy out as an m and a 4, but 128 still has some perfect square factors in it, so I can't stop there. All right, you want to continue to go until you are completely done. All right, so that's where we'll stop today. We'll worry about the fractions and the having radicals in the denominator tomorrow. I think this is enough to practice for today. All right, and then we'll go from there. So keep an eye on the e-board and the Google Classroom. We'll probably have a Google Meet sometime either tomorrow or Wednesday, just to go over this 10.2 stuff, because I know it's going to be pretty challenging for us at first. All right, so keep plugging away. If you have any questions, just reach out to me. All right, I'd be happy to help you individually if you have any questions.